with growing demand for new infrastructure projects as well as renovations of existing structures. The steel pipe pile market is now growing as strongly as the steel itself. Additionally, new technological advances are being made to improve the efficiency and cost-effectiveness of steel pipe pile installation. Steel piles are utilized in situations where the soil beneath a building is loosely packed, and there are concerns about the long-term stability of the structure. By using a pipe pile, the weight is evenly distributed and extends deeper into the earth, where the soil is more compact. This proves to be highly advantageous in the construction of super large buildings, where the soil alone cannot provide the necessary support. On the other hand, in situations where the land area is small and does not give enough room for spread footers or foundations, the forcing buildings will be used so that there is a better level of stability on the ground. Steel pipe piles are driven deep into the ground and act as anchors to transfer the building's load to the stable ground floor. Steel pipe piles are used in the construction of high-rise buildings and other structures to support the foundation. They provide a stable foundation for buildings and can also be used to reinforce existing structures. Bridge construction. Steel pipe piles are used in the construction of bridges around the world to support foundations known for their high strength and durability. And that's not all. Steel pipe piles are also superstars in coastal defense. They form the backbone of seawalls and breakwaters, shielding our shores from erosion's wrath. Need to hold back a slope or secure an underground structure? Steel pipe piles are your champion, creating sturdy retaining walls to prevent cave-ins. They're even the go-to for underground construction projects, shoring up mine tunnels and parking garages. The oil and gas industry relies on them too, providing rock-solid foundations for offshore platforms and pipeline dams. And let's not forget dams. Steel pipe piles offer crucial foundation support. Plus, they can be found in sluice and overflow gateworks. C. Steel pipe piles are incredibly versatile. They can adapt to any project's needs, and their location advantages make them a true winner. Let's talk driven steel piles. The pipe piling must be chosen carefully depending on the forces of the building, the prevailing conditions of the soil, and building codes of that area. The placement of piles is determined by a geotechnical engineer. The structural engineer then decides on the piling material and size of the pipe piling according to the depth which they must reach. In cases where a single piling pipe does not reach the required depth, piles are joined using splicing sleeves or butt welds to make them longer. These bad boys get hammered or vibrated, fancy that, into the ground to the perfect depth or resistance we need. They push the dirt aside as they go down, making themselves nice and strong at the bottom. To get the job done, need use either a super fast oscillating hammer or a classic pile driver. If we hit a real tough patch of soil, we might need to pre-drill a bit of a pathway first, especially if we want to save some muscle on the hammering. In the end, These piles become the rock stars of the foundation, taking on all the pressure from the building above, whether it's pushing down, pulling up, or trying to shove sideways. Now, to protect the pointy end going into the ground, especially if there's rocks around, we can weld a steel plate on the tip, and these piles can be hollow or closed off at the bottom with another welded plate. Those hollow ones, we can fill them up with concrete after driving them in for some extra oomph. Sometimes you run into a situation where the ground's tougher than a bull's hide and pile driving just bounces right off. That's when engineers gotta pull out the big guns. Literally, in this case, giant drills. It's a common trick, especially handy when you're dealing with a foundation full of rock. Thanks to today's fancy machinery, it's a whole lot easier. They take these huge 20-meter long drill bits, stick them inside a big iron pipe, connect them to a powerful drill, and get to work. The tip of the drill will be made of super hard alloy. These drills will penetrate the super hard rock underneath so that the steel pile can easily be driven down. Throughout the drilling process, soil conditions, depth, and verticality are continuously monitored. Drilling parameters can be adjusted if necessary. After reaching the target depth and the borehole has stabilized, the steel pipe pile is carefully lowered into the hole using a crane. With this method, contractors can shave some serious time off building those foundations. It's only when those piles meet up with some real tough rock that we gotta break out the drills. Cuts out a whole bunch of other steps. That's for sure. You ever wonder why those construction machines are so massive? It's because all that weight acts like an anchor, keeps them grounded when they're pushing or pulling with all their might. But that also means if you need a machine to push down with 100 tons of force, it's gotta weigh more than 100 tons itself. Otherwise, it would just float right off the ground. Huge machines. Sure, they get the job done, but a pain to move around and not exactly what you'd call convenient. Well, that's where the rotary cutting press in machine comes in, for jobs like installing those big hollow metal poles they use for foundations. This gyro piler thing, it's got a fancy cutting attachment that lets it carve its way down while it pushes the pole in. And guess what? It does all this without sacrificing the benefits of the press in method. Here's the good part. Less vibration and noise compared to those pile drivers that pound everything into place. Imagine the peace and quiet in a city environment. Plus, it can potentially cut down on a bunch of other construction steps since the piles themselves become part of the final structure. And to top it all off, they've even got an electric gyropiler that doesn't spew out any nasty fumes. Sounds like a win-win to me. Strong, clean, and gets the job done right. A steel pipe pile is a type of steel piling material that is commonly used to support and stabilize the foundation of a building. The most commonly used forms of pile pipes are typically large in diameter, ranging from 16 inches to 60 inches. These heavy-duty steel pipes can be manufactured using seamless, longitudinal welded LSAW or spiral welded SAW techniques. It all starts with high-quality steel coils. Manufacturers perform tests on these coils to ensure they have the right tensile strength and flexibility for the piles. The pipe is formed by spiral submerged arc welding technology. Spiral welded pipes are formed using narrower plates or hot rolled coils, which lowers their production costs significantly. The welding line shaped like a helix. The spiral welding process permits the production of large diameter pipes suitable for transporting large volumes of oil and gas. Some SAW pipes were historically limited to low-pressure applications. Spiral welded pipe is manufactured from coils of steel that are unwound and flattened. The flattened strip is formed by right-angle rollers into a cylinder of the desired diameter. The weld is welded under powder coating. This process is also known as submerged arc welding, SAW. At the end of the spiral, a new spiral is welded to the back edge of the pipe, creating a cross seam. The pipe is cut to length and the ends are beveled if necessary. Depending on the soil environments, the pipes may be coated with zinc, galvanized, FBE, or 3LP coatings. This helps to provide moisture resistance and corrosion resistance, enhancing their durability. Spiral pipe manufacturing has come a long way in recent decades. Cold bending of a spiral pipe was very difficult in the past, but thanks to better manufacturing processes, it can be bent even easier than a steel pipe with a straight weld seam. Spiral pipes also have close tolerances on the outside diameter and are to weld as ordinary steel pipes. Spiral pipes, like ordinary pipes, can be coated and lined without difficulty. This type of pipe is used in large pipeline systems around the world. And thanks to the spiral structure of the pipe, spiral pipe also has the most favorable properties for stopping a running crack. Because of these advantages, spiral welded pipe is used in a wide range of applications. Let me tell you about state-of-the-art pipe mill. This facility can churn out a whopping 650,000 tons of pipes every year. We're talking big pipes here, with diameters ranging from 508 millimeters all the way up to 1420 millimeters. And these aren't flimsy things either. The walls can be anywhere from 7.9 millimeters to 42 millimeters thick. They use top-of-the-line steel grades up to X100, and APF 5 cubic meters is the best in the business. But it's not just about raw power. The factory also dedicated to quality and sustainability. Every factory here has strict quality management systems that meet ISO 9000 standards and committed to minimizing our environmental impact with ISO 14001 compliant environmental management systems. To ensure every pipe is top-notch, they use a whole arsenal of non-destructive testing methods, including ultrasonic X-ray, magnetic particle testing, and hydraulic testing. Now, let's talk about protecting your pipes for the long haul. They offer a variety of external anti-corrosion coatings, including 2- and 3-layer polyethylene or polypropylene options. These coatings will keep your pipes safe in temperatures ranging from a frigid -60 degrees Celsius to a scorching 80 degrees Celsius. And the best part, with these coatings, your underground pipes can last for at least 30 years. They can also give your pipes an anti-friction and protective internal coating to boost your pipeline's throughput capacity by reducing friction losses during transport. And the beauty of it is, we can apply this internal coating before or after the external coating, whatever works best for you.
Comment c'est OK?
In order to construct a pipeline, staging areas and storage yards are cleared, strategically located along the planned right-of-way. These areas are used to stockpile pipe and to store fuel tanks, sandbags, silt fencing, stakes, and equipment parts. They provide parking for construction equipment, employee trucks, and locations for office trailers. Staging areas are cleared and covered in rough stone gravel, often reinforced with large wood timber matting. These areas can be located in fields, pasture, or forested land, and can impact streams and wetlands. Furthermore, the safety and execution techniques for pipelines entering a city are highly complex, owing to the movement of heavy equipment in crowded places and the large number of unmapped interferences. The trench for the pipeline is dug after the is cleared of trees. Sandbags are placed within the trench to restrict water flow and to support the pipe. When the trench is completed, pre-coated segments of pipe, usually 40 feet in length, are transported from stockpiles in the staging area to the right-of-way. Pipes are laid above ground beside the trench, or within the trench on top of supportive sandbags in steep terrain. Certain pipe sections are bent using a pipe bending tool to allow the pipeline to follow the planned route and the terrain. The pipe sections will then be welded together, sandblasted, and the weld joints coated with epoxy to prevent corrosion. Finally, the weld joints are inspected with X-ray to ensure their quality. Welding pipe is one of the most challenging tasks any welding professional can do, due to the sheer number of procedures necessary to create a quality pipe weld. Pipe welding requires versatile skills and a lot of experience. Couple this with the harsh working conditions, and you get a job not everyone is meant for. Pipe welding needs to be done promptly and without faults. You can't fall behind the schedule, and repetitive mistakes typically result in losing a job. Provided welding procedures and specifications must be rigorously followed, and the inspector will make sure they are. Typical pipeline welder day starts with a morning brief where everyone gets their assignments for the day, including the number of welds or inches they must complete. Everyone relies on the welder to achieve the required welds. If the welds fall short of the required standards, the welder must make repairs, which can be problematic and push back the dates. To ensure pipeline integrity, welds must be X-rayed and the pipe hydro-tested. This process involves pumping in clean water, pressured above the expected maximum average operating pressure. Then all water is removed and pigs are inserted into the pipe to clean it out. When the pigs eventually exit the far end of the pipe clean, then the line will be filled with dry air. Air compressors pump up the air, and the air is run through a dryer. The air will be sampled and tested for moisture content. When those parameters get low enough, the complete pipeline is filled with nitrogen to absorb more of the remaining moisture. Only then is the pipeline ready to transport natural gas.